Pointers are the most fair topic in C programming, but in the next 5 minutes, I will make pointers so simple that they will feel like basic variables. Hello everyone, welcome to One Shot Coding. Today we will understand pointers from absolute basics with syntax, dereferencing, size of pointers, rules and memory relationship. Let's start. What is a pointer? A pointer is a variable that stores the memory address of another variable, not value. It stores the address of another variable. Let's see the syntax of a pointer. So in the syntax, we first write data type and then we write pointer name with star. Here, star means a pointer and the pointer name stores an address. Let's see the example of the code. In this example, we are creating a variable integer x equals 10. So we are just creating a normal variable. Then we are creating a pointer. We are writing our data type star p. So this is a pointer declaration. We have declared a pointer p. In this pointer, now I can store address of a variable. How we will store address of a variable? Let's see the third line. We use address of operator to store the address of a variable inside a pointer. Here you will see we are writing p equals to ampersand x. Let's see with the diagram how data will be stored once we write this code. Once we write the first line integer x equals 10, a container gets created for x. Suppose this is our x. This variable will have its own address. Let's assume the address of x is 1000 and we have inserted the value 10 inside our variable x. Then we are creating a pointer p. So once we create this pointer p, another container will be created similar to our variable x. This is our p and it will have its own memory address similar to our variable x. So let's assume this pointer is having address 2000. After this, we are saying p equals to ampersand x. This symbol ampersand we are using, this is called ampersand. And this is a address of operator. It is also called unary operator. Why it is called a unary operator? Because it works on a single operand. So here if we notice, we are writing ampersand x. X is a single operand. So this is why our ampersand is a unary operator. It gives us the address of a variable. So once we write p equals to ampersand x, we will get address of x 1000 and this address of x 1000 gets inserted in our pointer p. So the value 1000, this is the address of x, this will be inserted in our pointer variable p. This is how our pointers are created. Let's move. Here I have written 2 points. X. Here our x is a normal variable storing value 10. Whereas our p is a pointer storing address of x. So we can see here our p is a pointer. It is storing the address of x variable. I hope now pointers are clear to you all. We will now move to our second topic, dereferencing of a pointer. Before moving to dereferencing of pointer, let's write the code of the pointer. So I will move to the code editor and we will create a pointer. So if we want to create a pointer, our first step will be we will create a variable. So I want to store the variable. Suppose we have x and we are assigning the value of x as 10. Now I want to store the address of x. So we know we have a special variable pointer. In this variable we can store the address of x. So we will create or we will declare a pointer. So how we declare a pointer? We write first the data type, then we write a star, then we write our pointer name. So suppose our pointer name is ptr. Now in this pointer we can assign the address of x. So we can write ptr equals to ampersand x. Now we will write to print the values, we write printf. Inside printf will pass %d, our format specifier, comma, and we can give our pointer name. And we'll close our line with return 0. Let's first run this code and see the output. To run the code, first I will write a command gcc my file name. So my file name here is pointers.c and gcc is our compiler of the C. So we write this command gcc our file name. It simply compiles our code. In the next step, I am writing a command dot /a.exe. This command runs our code. It is used to execute our code in Windows. Once you press enter, you can see some numbers are getting printed. This is nothing but the address of our pointer. Now let's get back to our slide. So we have created a variable integer x equals 10. Then we have created a pointer integer star pointer and we are storing the address of x inside our pointer. After this, we have just printed the pointer. Let's move to our slide. Here, now we will see our second topic, dereferencing of pointer. Now, what is dereferencing of pointer? Dereferencing means accessing the value stored at the pointer's address. If I want to access what is the value stored at the address. Okay, so this is only called dereferencing of pointer. So to dereference a pointer, we use the star operator. Okay, we use star operator that is written here, you can see. Okay, now let's see the same example. Here we are writing integer x equals 10. Then we have created a pointer integer star p equals ampersand x. So we are storing the address of x in our pointer p. After this, while printing, we are writing printf %d comma star p. So instead of just giving our pointer name, we are giving star p. So we are dereferencing a pointer here. So this will print us the value stored at the address. As for example, I will again draw a diagram here. So once we create this x variable, as we discussed in our last slide, this is our x and let's assume this is the address 1000. In x we have value 10. Then we created a pointer p. So a p pointer gets created and this pointer also contains its own address. Suppose 2000. In this pointer we are writing assigning the address of x. We are writing integer star p equals to ampersand x. So we are giving this address of x. So address of x is 1000 here. So this 1000 we are inserting inside our pointer p. So our pointer p starts referencing to x variable. Okay. Now in dereferencing we write star p. So we say that star basically means value at. If we write star, it basically means value at. It is called asterisk in English language, normal. And this is also a unary operator because it works on a single operand. So it is a unary operator. Then this is also called dereferencing operator. Our star is called dereferencing operator. Now we are saying star p. Star p. What is the value at this address? Okay. So inside our p, we have 1000. Let me delete this one. Okay. So inside our p, we are having value 1000. So we are saying star p. What is the value at 1000 address? We are saying what is the value at 1000 address? So we are having 10 at 1000 address. So that's why our value 10 will be printed. I hope this is clear to you all. Now here I have written p is address of x. So our p is a pointer variable. It will contain address of x. While star p means value stored at that address. So if we are just writing p, if we are printing p, it will print the address of x. So it will print as 1000 because inside p we have stored 1000. That 1000 is the address of x variable. But if we are writing star p, we are getting the value stored at that address. What is the value stored at 1000 address? So at 1000 address, 10 value has been stored. So that's why we are getting this 10 output. Now let's again go back to our code editor, and previously we run our code by just giving the pointer. Now we will do the dereferencing. So here I will add one more line and I will write printf %d comma star ptr. And now let's run the code. So here what we are doing, here we are dereferencing. We are dereferencing our pointer. So I will go to the terminal and I will run my code. So we'll write gcc pointers.c ./a.exe. So we are getting two outputs, but both the outputs are getting on the same line. So to move the output to the new line, let's add /n here and we'll save our code, and I will again run the same code. Let's run the code. Now you can see the output here. Our first value is the address and the second value we are getting 10. So in the first line we are printing PTR. This is giving us the address of X. This 642226 is the address of X. While in the second line here, once we print star PTR, we are dereferencing our pointer here. So we are getting the value 10 printed. I hope this is clear now. Let's move back. Now we will see size of pointers. We know about our data types, right? We have data types like we have integer, character, float and double. So if we talk about integer, we know the size of integer is of 4 bytes. If we talk about a character, we know character occupies 1 byte of memory. If we talk about float, we know float occupies 4 bytes of memory. While we talk about our double, we know double occupies 8 bytes of memory. But here, pointer's size doesn't depend on data type. Our variable's size depends on data type, but our pointer size does not depend on data type. Here I have written a point. Size of a pointer in C depends on the architecture of a machine. It will depend on the architecture of our computer, not the data type it points to. So what will be my size of pointer? So if we are having a 32-bit system, all of our pointers will occupy 4 bytes of memory. And if we are having a 64-bit system, all our pointers will typically occupy 8 bytes of memory. So we have already created our pointer, correct? So we'll go there and we will print the size of our pointer. So I will move to the code editor again. So here we created a pointer, teacher star ptr. Let's remove all of these codes, okay? And I will create a simple pointer, integer star p, first pointer. Then we'll create a pointer of character type, character star p1. This is p2, and suppose this one is our p1. Now I will create another pointer of float type, float star p3, and let's print the size of each of this pointer. So to print the size, we will write percentage %zu, and I will give /n to move the line output to the new line, and then we will use a function size of. In this function, we will pass our pointer name. So it will give us the size of our pointer. Now we'll just copy this code and write 2 more times. So I am running the code. Here we'll print the size of p2, and here we will print the size of p3. Let's run this code and let's see the output. If you notice, we are getting output 444. So because my system is a 32-bit system, all of these pointers are having the same size, 4 bytes. That's what I told you, that it will not depend on the data type. Suppose my first pointer data type was integer, my second pointer data type was character, my third pointer data type was float. So it will not depend on these data types of my pointer variable. It will depend on my system architecture of my machine. So that's why for each of this pointer, our size is 4 bytes. If your machine is 64-bit system, then you will get the output 8 bytes. Let's move to the next point, pointer declaration rules. So we can create pointer of all data types. Like if I want to create a pointer of integer pointer, so we will write integer star p. Here this is a pointer to integer. Then we can create a pointer of character type also. So I have written a code character star c. This is called pointer to character. If we create a pointer of float type, then it is called pointer to a float. Now here I will tell you an important point, that our pointers data type should be same. What I am trying to say here is, suppose we create a variable integer x equals to 10, and I want to store the address of this variable x. So we should always create a pointer of integer type only. It should contain this, it should be of same data type. I will create a pointer integer star p, and I will store the address. I will assign address of x by using the ampersand symbol or address of operator. So we will write address of x. So the address of x will be stored in my p pointer. So the data type of the variable and the pointer must be saved. Now, second point, we should always initialize our pointers. It is a good practice that while declaring a pointer, we should initialize our pointer with null value. Because if we do not initialize our pointers, so initially it contains garbage data. So to overcome this, we should always initialize our pointers with a value called null. Now, let's see one more topic here, the relationship between a pointer and a variable. Okay, let's see this code. In this code, we are creating a variable integer x equals 5, and we are writing integer star p equals to ampersand x. So we have not done anything. I will draw a diagram only here. So first we created a variable x. So our x will be created something like this. And suppose the address of x is 1000. In this x, we are having value 5. Then we created a pointer p. This is our pointer p. And suppose it is having address 2000. In this pointer, I am storing address of x. So the address of x is 1000. So 1000 we have stored in this pointer. Now, we are saying star p equals to 20. And once we print this, this will change the value of our x variable. How it will change value? I have written up one point here. Changing value using pointer also changes original variable. I will again repeat. Changing value using pointer also changes original variable. How it changes original variable? We are saying star p equals to 20. So I told you guys that this star is called value at. This is called value at. We are saying what first, let's see what is inside our p. Inside our p we are having 1000. This 1000 is address of our x variable. So we are saying what is the value at this 1000 address? What is the value at this 1000 address? Update this to 20. So at 1000 address we are having the value 5. This 5 will be updated to 20 once we write this line. So that's why it is written that anytime we will change the value of a variable using a pointer, it will change the original variable. So let's run this code also and we will see the output of this code. Let me remove this code. So let's suppose we have a variable integer x equals 5 and we are having a pointer p1 p. In this I am storing address of x. If I write star p equals to 20 and we print, we'll print the value at, let's print x. Okay, first let's print x and let's see the output. So I will write gcc pointers.c to compile my code, then dot / a.exe to run my code. So you can see the value of x is coming as 20. So our value of x was initially 5. Then we updated the value by 20 using our pointer. So our output is coming as 20. Correct? Let's come back to our slide now. Now, let's finally recap what are the topics we have discussed till now. After this, we will be covering about pointer arithmetics in our next slide. But before that, let's see what are the topics we have discussed till now. We'll quickly recap our topics here. What are the points we discussed? We discussed about pointer. What is a pointer? So I told you that pointer will store the address. So our pointer stores address. Our next point. What is a star? This is star equals to is our pointer syntax. So if any time I want to create a pointer variable, I will write star variable name or pointer name. This is our pointer syntax. Then what is this ampersand x? It gives us address of variable. Ampersand is address of. So anytime if we write address of x, it will give us address of a variable x. Then if we write star p, it means dereferencing. We are doing dereferencing. Then one more point, pointer and variable share memory. Okay. And the last point, pointer size will depend on system, not on the data types. So these are some points we have discussed in this video. Pointers are not difficult. These are just misunderstood. So in the next video, we will deeply visualize pointer memory using diagrams. Please subscribe to One Shot Coding and Master Programming with Real Understanding. Thank you all.